Start recording again. All right. Share my desktop. Make sure that works. Oh yeah, okay, that's the one that's currently going. 9:25. Okay, so let's look at the lab for today. So did anybody have trouble accessing the these courses? If you had trouble, let me know. So what you're going to do this time is you're going to do what we just did in class, but you're gonna follow a course that's going to show you how to do service area, closest facilities, and then optimized routes, which is really a variation of the service areas. So these are all network analysts tools in ArcGIS. So
these are entry courses?
These are entry courses.
Okay.
As you work through them, if you have any questions, let me know. And once we're done talking about the test that's next week, then I'll be around to answer questions, both on this lab and the next one for about another hour. You know, and I can up to 3:30. So the next thing is you have to answer a question. So you're gonna have to describe each of the analysis types you ran above. It's like a 2 or 3 sentence description there. And then for each one, think of another real-world example of how they could be used in a different scenario other than what was presented in the exercise and describe it.
For the 3 things there, is that all one module on
No.
or?
So 3 different modules.
3 different modules?
And each one says they take under an hour to complete.
And you just turn in this
1 hour.
Right.
Do they give us certificates like the first one?
They do.
Okay.
Yep. Turn in the certificate. Good part. And actually, what I just said was wrong. I thought this. Anyway, these are all different concepts. Optimized route is not like service area. It's the shortest path, I think. All right. So fill in. Do each of these. Each take about an hour. Turn in the certificate and turn in the answer to that question. And that's it for this week. That's what I meant. That it's not an intensive week. So because you also have the exam next week.
Did you update your exam or your test book or your questions?
I did. I updated it all. Hold on a second here. I'm going to. I should have done this during the break. Okay, so here is, if you go under, I also moved it, so it's down here now. It's called Vector Graphics Exam 1 Review 2019, and it is very, very similar, if not exactly the same as it was before, but I did add the section on network modeling. So we're going to go through this right now. Okay. And before I do that, I'm going to also have the actual exam up that I've already written up in up on the other side, so I can refer to it. Google.
So you can throw it up on the screen?
That's why I'm putting it on this little screen. Yeah, that'd be nice.
We're gonna go over.
So we can peer edit for you if you need someone to look it over. Check for grammar.
Check yours a little bit.
Yeah, I do need somebody to check for grammar. Definitely. Okay. All right. So, so the test is going to be mostly short answer. So, like things that could be answered in either a word or a phrase or sometimes a sentence. That's going to be 90% of the questions are going to be like that. So there will be a couple of longer questions that might be 2 or 3 sentences, but there's no like entire paragraphs or anything like that. There's no like essay questions. There are let's see how many of these there are. I think there's there are some multiple choice questions, just a few, and there are a few questions where you have to. Sorry, there's only one question where you might have to draw a diagram, like a ArcGIS diagram, like in Model Builder, like draw the process. So basically, there's like a 3-step process to solve a problem, and you have to either draw a diagram or write each of the 3 steps. So that's the closest thing there is to like an essay question, but it's more like, you know, solve a question. So similar to the questions from Lab 3. Sorry, go ahead.
Are those questions based on what you said, or a combination of what you said and also the book definition, not book, but the online?
Right, the readings.
Yes.
Well, that question that has to do with knowing what steps to take is very similar to the Lab 3 questions. So I would go look at those. So basically, you know, like you'll need to know if a particular thing needs to do a select, then a dissolve, and then select a spatial join and then a dissolve, or a select union and dissolve, something like that. Okay, but it'll be a fairly simple problem that only takes 2 or 3 tools, but you'll need to describe the process that's going on. All right, and then the other questions. So there's one that's actually the opposite. It's showing actually have a model, and it's showing what's going on, and you'll need to actually describe the output. So the model's there. You'll need to describe what the output contains.
Is this based on the tool? Can you describe that model? Does that tell me what the tool is that we're using? Or
the model will show. So the model it'll be a model, and the tools. If it's a union, it'll say union on it. So I'll have an input, and it'll say union. If it's an intersect, it'll do that. If it's a buffer, it'll do that.
But you still need to describe the output.
Yeah, you describe the output. What's in the output? All right. Then there's a overlay question where I have 2 polygons that overlap each other. You can kind of see where the boundaries are, and you'll have to know what the output table looked like.
Based on the picture that you were shown, it's a different picture you have to select.
I have the input table for both. I have a picture of what's going on, and you'll need to draw the output table.
Oh, you have to draw it. So you don't have a picture to select which one is the correct one.
Right. So the output table, you'll need to know what fields go in the output table, and you'll need to know how many records there'll be in the output table, because there's only going to be 2 input polygons that overlap each other.
Okay.
Yep. All right. So these are all the questions that aren't. So I got the one. You need to describe how to do it, the process. You can draw a model if you want. We got that one. These are the ones that aren't just short answer. I think that's it. So there's the rest of them are short answer. There's about 30 questions. Sorry, go ahead.
But if you know all these areas on this paper here, then there's the test, everything encompasses those particular things you're highlighting. That's what's going to be.
Yeah. So all the short answer is going to come from what I talk about now, and even those questions that I just brought up, they rely on concepts that I'm going to talk about.
So you're gonna include the network questions, or we should already know based on what you're saying? You're not gonna type add network questions to this document, are you?
Ah,
Are you gonna add any network stuff in?
I did add the network stuff, but it didn't get added. Dang it.
But it's gonna be what we covered today, right? I should we just assume that?
See, I added it,
Oh, okay.
but it didn't
Upload the canvas.
upload to Canvas correctly. Here, let me try again here. So, modules. It's a good thing we're reviewing it. Remove. Plus. File. New file. Choose file. It's this one. Let's try to download that one. So now it's called -1.
I got it.
That works.
It's on my.
All right, good. Yeah, so the network stuff's going to be on there. All right. So let's review the rest of the content. And yeah, it'll be taken from things I talked about in class, but the reading sometimes will help that solidify that. But if it's only in the readings and never even mentioned it, it's not going to be on the test. All right.
So you always test based on what you say, not what we read, right? You always try to test by what you actually cover.
I mean, yeah, for the most part. But today, I mean, this will be like that. I mean, usually there's a deeper understanding in the reading, and sometimes that will help you answer the question correctly.
Okay.
But yeah. So okay, so basically the first question here, I mean, the first thing I have written out here is, how is the vector data model unique in GIS? How is it different than raster? You should know all about the vector data model, that it's points, lines, and polygons. The points, lines, and polygons are stored, a polyline and a polygon are made up of points, and they're stored in one area, and the attributes are stored separately as a table, and they're joined. They're linked together. Okay. But it's basically tabular data with associated points, lines, or polygons. That's the vector data model. So here, when I say what are the strengths of the vector data model, you might have to supply a real-world example of something that would be better modeled as a vector data model rather than as a raster data model. So if elevation can be modeled in vector by using contour lines, but its strength isn't doing something like that. Its strength is in modeling something like a road network. That'd be very difficult to do in the raster data model. Things that are naturally points, lines, and polygons and have definite boundaries fit into the strength of the vector data model. Whereas things that are continuous fields more often are better modeled as raster. You can pretty much model any data set as either one, or any real-world entity as either one. But some fit better in one or the other. So on the test, you might be asked for an example of something that is, and why. Okay. All right. we did talk a little bit about this. I know we introduced it in 217, but here we have this question as attribute measurement levels, whether something's nominal, ordinal, or interval ratio. And notice that there's no comma between interval and ratio. So basically what I'm looking for here is that you can distinguish between a field that's a label, or a field that has an order, or a field that has a real number that actually means a quantity. That's what each of these mean.
But on the, in a statistical, you take statistic, nominal, ordinal, and interval ratio, we know the same thing, but they make the same statistics.
Interval ratio, there is a difference between interval data and ratio data. So interval data is data that has an arbitrary zero, and ratio data has a real zero value. So a quantity that is interval is elevation. There's no such thing as a lack of elevation. There's no zero elevation doesn't mean you don't have any elevation. But zero, I've eaten no food today, or I've eaten 2 kilograms of food today. Those are ratio numbers because zero means something. But a better GIS example would be precipitation. Zero means no rain fell. It means there's a lack of precipitation. But the point I was trying to make is I make no distinction about that on the test.
Pretty much interval and ratio are representing an actual number that means something. So like
Right.
population, something like that.
Yep. So if you're looking at an attribute table, you should be able to tell that a particular field represents something that is a nominal, ordinal, or interval ratio, regardless as to whether or not it is actually a number. Like, what if it's a number? Well, then just because it's a number doesn't mean it's interval ratio.
Right. Like the nominal or ordinal.
Yeah, like if, well, like in the case of the thing that we did today. So those numbers that were just the point ID. Okay, there's no measurement level. The only measurement level is the point ID is a label, whether or not it's a number or not. If it was the name of a county or something, then that's also just a label, so it's nominal.
Ordinal would be first, second, third, fourth.
Mm-hmm. Yep, high, medium, low, 1, 2, and 3. All right, spatial autocorrelation. Okay, we talked about this a few times in this class. This will be hit a little bit more on the last test, but for now, because that's what we're going to get into, that's what all those other lectures are about, or what's one of the things that they're about. So what is the general definition of spatial autocorrelation? It's basically you should understand that here's Tobler's first law of geography written in a different way. The fact that locations near one another in space are more likely to be similar than data from locations from a remote area. Okay. All right, we talked about 2 other concepts related to spatial patterns, and that was the modifiable aerial unit problem and the ecological fallacy, and both of these are related. The modifiable aerial unit problem, if you could go back in the text or the readings or even the slides, talks about the issue of aggregation, and as you aggregate at different levels, you can get a totally different answer for whatever you were trying to do. So unemployment, like let's say, what's the unemployment? Well, the unemployment is obviously going to be different in Hattiesburg than it is in Mississippi as a whole. Okay, but we can't. We might see a different pattern. So the modifiable area unit problem is all about the pattern that's apparent, and the ecological fallacy is actually about saying Well, the unemployment in Mississippi is 30%. That's horrible. All right. I don't know if it's anywhere near that. Then the unemployment in Hattiesburg is also 30%. That's the ecological fallacy, is making assumptions about a broad group of people based on, a specific group of people based on a broad group, or vice versa, actually. So those are those two. They're pretty well explained in a few of the slides, but also in some of the readings. All right, so the term geoprocessing, you should be aware that that term is oftentimes a ESRI specific term for the chaining up of different spatial tools. It's called geoprocessing. All right. So you should understand a little bit about spatial relationships. If I ask you to provide an answer looking at a bunch of polygons, and I say which polygons are adjacent to polygon A based on the criteria that they need to be within 5 miles of the polygon, then you would specify which ones. Obviously, I have to give you a scale in that case. If I say that which ones are adjacent based on the fact that they share a common boundary or a one-dimensional spatial relationship, one of those two ways, which is the same thing, which ones are adjacent? Okay, those are two examples. So those are things that might appear on the test. All right, the definition of proximity is how close together they are spatially. Intersection, if I say which features intersect, that means that they touch each other in some way. But containment and within are a little different in that they contain the containment's fact that it needs to totally surround the feature. Within means to be totally inside of a feature. Does feature A contain feature B? That means that feature A needs to be totally out around feature B. Is feature A within feature B? That means that feature A means to be totally inside of feature B. So they're very similar. Yeah?
They mean the same thing, essentially? Like, I don't understand what's different about them. Containment and within.
Okay. They are talking about the same spatial relationship, but containment means, okay, listen carefully. Does feature A contain feature B? That means that feature B must be totally within feature A. So they're almost like opposites, right? One is asking, are you, like if I'm hugging somebody, are you the person being hugged, or are you the hugging person?
All right.
Like if I say, does A contain B? Well, it's only true if A is hugging B. B does not contain A. B is within A. Does that make sense?
Yeah.
Yeah. So you might have some spatial relationship questions. Does B contain A, or is B within A, or is well, I already gave the proximity example, but does A intersect B? Things like that. All right. Basic spatial relationships, but then the reason why you need to know those is because of the spatial join operations. So spatial join operations, you'll need to know for a spatial join operation, and actually for any join operation, you've got a table that is receiving the data. That's usually called the target data set, or the destination sometimes. The target or the destination data set. And then you've got the other data set that is sending the information. And that's usually called the source, or the, what's the other word for it?
The join table?
Yeah, sometimes it's just called the join table. I think there's another word for it. Anyway, the other one, the one that's sending the data to the other table. Okay. And so when you do a spatial join, it's just like a regular join, except for you're joining based on a spatial relationship. Okay. All right. Actually, I should probably take that off. Yeah, I'll take that off. Save that. Okay. So you should be able to like specify which one is which in an example. All right. So for overlay, let me see here. I don't want to say anything that's false. Just looking through the test, I do not see anything besides union and intersect. I know we discussed each of those types. So looking at union and intersect, remember all the overlays are basically the same. It's just how the geometry is different. And so you should know union and intersect and how the output is different in each of those. All right, you should be able to calculate. You should be able to know when you should calculate a new field, including calculating the geometry, which is very similar to calculating a field. In other words, getting the something about the feature, the centroid, or the XY coordinate. All right, you should be able to identify why you would do a dissolve. Really, a dissolve is all about summarizing data, right? You're dissolving common boundaries and creating a new feature, and you get to choose what features get put together. I'm not going to say join because I think that might get you confused. It's not the same as a join, not at all. Dissolve, you put features together based on a common attribute. And then optionally, you can summarize something about another attribute. That's why we did it today in our data set. I mean, in our overlay exam. I mean, our origin destination example.
So merge the neighborhoods boundaries if the neighborhood has the same attributes.
Mm-hmm.
Those are looped, they have the same attributes.
Yeah, there are basically two important inputs to a dissolve: the dissolve fields and the statistics fields. So the dissolve fields specify what's going to become one feature. Anything with the same value in the dissolve field becomes a new feature, and then the statistics fields summarize. Because you're aggregating features together, they summarize the total or the mean. They aggregate that other field based on what the original values were. All right. So append and merge, really, I don't think there's a difference on the test, really. So both of these basically combined two data sets. I don't think we ever did that in the lab. We might have, maybe with the counties lab, where I had you download, 3 counties worth of data, combine them together. That's probably where I implemented it. So they're tools for basically pushing data sets together. So I've got the data in Lamar County, data in Forest County. I want to combine them. Well, append would let me add it to one of the other data set. What's much more common is to create a new data set that is the result of two data sets. So Lamar County's data and Forest County's data, combine them together. That's a merge. It's a merge tool. Clip is kind of like an overlay tool, but it doesn't cause any of the attributes to change. It just cookie cuts out the extent for you. And erase is kind of the opposite, but I don't think the test doesn't talk about erase at all. But really, erase and clip are almost the same. It's just whether you're saving the cookie or you're saving the extra parts. All right, so yeah, go ahead.
They are removed pieces that overlap.
Yes. So the clip removes any feature that doesn't overlap. It's like doing an intersect, but none of the features change. They're just clipped. They're just cut to the extent of the clip feature. All right. The buffer and the proximity tools. Well, the buffer and the rest of the proximity tools. I think the only other proximity tool that's on the test is the near tool. What does it do? It finds the distance to the nearest feature in another data set. So you're given data set A, you get data set B, and every feature in data set A is given the distance to the nearest feature in data set B. And buffer, I think we've covered well enough. Everybody understands what that does. All right, so there are some questions on just plain old table joins. Okay.
Dr. Ray, with that near to, when we were trying to do that networking thing, we were trying to find the one that's nearest to the shortest point, the nearest center or something. Is that how you use that tool? Near to, you can see how close you get to a particular point?
No, the near tool was back before. It doesn't have to do with networks.
Okay.
The near tool is a proximity tool. It's for finding out how close things are to each other. It'll actually be a building block for some of the analysis that we do in the second half of the course. That tool. Okay. So table join. Yeah, you should know you have to join on a field. That's a table join when you do a join on a field. There are two different types of table joins. One makes a brand new data set and one doesn't, but that's actually not on the test. So we have join types, and ArcGIS, remember we had that kind of thing where we found out that ArcGIS calls almost everything that you're going to do a one-to-one join type, but yeah. But really what you need to know is that when you join data to another data set, and there's more than one possible join. In other words, there's more records from A that can be joined to B, then you either have to summarize, and ArcGIS still calls that a one-to-one, or you have to wind up with more records in your table that you originally had. Okay, so you'll end up, if you have a join that one record joins with 5 other records in another table, your output table will either summarize those 5 records, or it'll have now 5 records in the output table, one for each of those joins. That actually has to do, that's the definition of cardinality, is whether it's one-to-one or one-to-many. We're not going to talk about many. There's no many-to-many types of questions on the test.
So you're not gonna have like, you can join this database, is it a one-to-one or a one-to-many or many-to-one, like nothing like that?
Right.
Okay.
So the test questions would be more like, after the join here, how would these 2 records be handled? And then, summarized. So the source versus destination is important to be able to recognize which one's getting the data and which one's giving the data. Which one should be. So given a particular scenario, which one should be receiving the data and which one should be giving the data. Which one's the source versus the destination, or the target versus the join table. All right, so now we're getting all the way up to last week. So last week we talked a little bit about GIS and the levels of science. So just look for the definitions there. You should be able to distinguish different types of models that we talked about. Specifically, let's see here. And we talked about natural versus scale, and we talked about well, the only other one that I have on here is capability suitability modeling, which is the next one. Yeah, so capability suitability modeling, and we talked about 3 different types, almost 4 from the lecture, but really pass-fail screening and Boolean are the same thing. So we got Boolean or pass-fail screening, where the data sets are combined and they're just given values of 1 or 0. The ordinal combination means that they're combined using some mathematical function, whether that be adding, subtracting, usually not subtracting, but addition, or the minimum or the maximum value. And then weighted linear combination means that each input is given a weight. The weight is multiplied to the value, the factor, score, and then all those are added up. Okay. So when I say math included, you're not actually going to have to write down any mathematic formulas, but you'll have to recognize that a particular a description of one of these is a certain type. So here, let's say I say that the overall suitability areas are the addition of each of the factor scores. Which one of those does that fall into the best? Okay. Something like that. Which one of these allows weights? Well, that's the weighted linear combinations. That's not the exact question, obviously. All right.
Ordinal does as well, correct? It's in rating order.
The ordinal combination is the one, well, it involves factors, which you could call weights. Yeah. You're right. Yeah, that wasn't actually a question on the test. That was just me trying to come up with an example test question. Okay, the first one was though. All right. Yeah. So this is what I already said. Be able to diagram a simple two-step process. So in other words, the example that I'm going to have on the test is just going to be a simple two-step process. So there'll be one process and another process. You don't have to put them together. And then the opposite. I already talked about both of these. All right, so from today, what's going to be on the test? Well, we're going to, let's see. We really didn't talk about the other types of networks.
Hey, once we take the test, will you leave, Dr. Ray?
Will you leave? Yeah, you can.
I mean, that's the rest of the day, right? You're not gonna teach it for that day, right?
No, that's right. I'll be around to help with any questions anybody has, but we're just taking the test. Okay. So you do need to know about the fact that a network can have flow in either direction. So you can actually have, in order to model that, we didn't actually show how to build a network, but you'd have to have an edge. Every edge could have a from and a to cost associated with it. And so you can have a network that has a different cost associated with flowing in different directions. So you have to know that. And then that's the only real types of network questions. There's no questions about a utility network at all. Okay. So you should know some network terms. Oh, sorry. Go ahead. Do you have a question?
I just didn't hear what you said at the very end. You said there's going to be no questions. What?
There's going to be no utility network questions.
Okay.
It's all on the traditional transportation, what ArcGIS calls a transportation network. All right, so you should know network terms. Junctions are the point where two edges meet. Nodes are points in the network, and edges are lines in the network.
Edge connected to nodes, correct?
They can be, or they can be connected to other edges at junctions. But junctions are not points in your data set. Like, in other words, they're not modeled as points. They're just the connection between edges.
And edges can be connected to other edges, like one road turns to another road. That's an edge to edge, correct?
Right.
Without being crossed.
There doesn't have to be a node at the junction. There can be a node at a junction. And in fact, you can actually have, you can create a network and you put a node in the middle of an edge if you wanted to. Typically that's not done, but edges, the nodes are the networks, I mean the points. So weights in a network can be actually attached to edges and junctions and nodes. It can be attached to anything. And networks can be bidirectional.
And that's the same as cost, right? Weights.
Yes. So weights are the attributes that represent cost. I did use that term interchangeably. But yes, they're the same in this case. So you should know the type of problems and be able to identify which one would help a specific problem. Shortest path, best route, closest facility, service area, location allocation, and the OD cost matrix, the origin destination cost matrix.
So what you do is you write the question and we'll select which one are we trying to accomplish.
Right.
Right.
Yep. So what is centrality? Centrality is a measure of how connected a node or an edge is within the network. And I only talked about 3 different types of centrality. So you should be able to identify which ones are which. So degree centrality is how many other network features are connected directly to that one. Sometimes I can say, okay, I want the connected to the nth degree, like the 2nd degree. In other words, not just how many are connected directly, but how many are connected to that one, and then how many are connected to those that are connected to that one. Okay, that's degree centrality. Just how many connections are flowing into that feature, whether it's a node or an edge. And then closeness centrality is the sum. It's defined as the sum of all of the paths from that feature to every other feature of concern. It could be all the other nodes. It could be just a select number of nodes. It's the sum from that feature to every other feature that's of concern in the network. It could be all the other facilities. What's that?
So the least distance between that point and the rest of the points?
Yeah, only if distance is the weight that's being used in the network. If it's time, it's the one that has the shortest time to all the other locations. Does that make sense?
Yeah.
And then the general term in math would be the weights. It's the one with the smallest value. All right, and then finally, betweenness centrality is the one that like Ashley brought it up, and I think it's a good analogy. It's the one that serves as a bridge the most often between the features of concern that you're looking at, in the shortest path between all the other features.
Could you use this degree of centrality when you kind of find people and who the worst areas, this they never fall into? It gives a degree of centrality and can show you the closeness they are to each one you bring up.
Yeah, if you model the social network, you could use betweenness centrality to like find out who was the person that would be most likely to see, all the other people in a day or something like that. Yeah. So this was a terrorist network. Is that what you were asking?
But it's the same thing, right?
Right.
All the edges would be all the different people going into the nodes of that person.
Yeah, you probably model the people as the nodes, and the edges would be the strength of their relationship, and you could measure it in lots of different ways. How you can measure the strength of the relationship is how often they make contact with each other. You can measure the strength of their relationship in terms of how easy it is for them to talk to each other. Lots of different things. But yeah, you could do it with a terrorist network for sure. I just didn't know for sure if I heard you correctly.
That's correct.
All right. Any other questions? Okay. Yep, that's it. So I'm going to get a drink of water because my throat hurts. But I'll be back here in 5 minutes if anybody has any more questions. For right now, I'm going to stop the recording.